Hi, welcome to our brief demonstration of our updated virtual bioreactor training simulation game. This is an updated version of the virtual bioreactor that we have been working for quite some time. Now, here in this particular instance, we have tried to demonstrate a penicillin production simulation process. So you can see in the screen, there is a 3D model of a steam bioreactor, and as our previous game, you can interact with different objects and equipments, and you can walk around uh, in a room scale environment in the virtual world. Now, when simulation-based training is concerned, currently there are mainly two technologies. One is like the virtual reality training that you are seeing here right now, where we usually do, people usually train uh, for procedural task where the trainee has to do something with their own hand. For instance, like setting up the virtual bioreactor. And there is another form of simulation, which is the desktop-based simulation, and those simulations are mainly used for like heavy calculation-based simulation works. Now, what we try to achieve here is to merge these two paradigms into a singular, in a singular packet. So, as you can see, this is yeah, you can see there are acid bottles and alkaline bottles, and these are the pipes that is feeding alkaline and acid through the pump to the system. And this is a penicillin production process, and this is the display, which is basically we can also project it here, but for convenience I have just zoomed it out. Now, here in this game, like we have in the back end, there is a simulation running, which is a simulation that is based on mathematical models and real life data from multiple penicillin batches. So this so here you can train people not only for offline scenarios but online when the bioreactor is running. So for instance, you can see the pH level is around 4.95, and we have set up an alarm at 4.9, and this is the dissolved oxygen. As it is a PID control, uh, yeah, it is a PID control based system. So when the um, the alkaline level, pH level goes below a certain level, there is a burst of uh, alkaline or acid from the pumps. So as you can see, there is a spike here, which corresponds to the spike of the pH, because the pH was dipping down. Now we have set the alarm to 4.9 for uh, so what it does, this like this system, what it helps us to expedite things. So in real world, if we want to train people with the actual setting, we would need a lot of time, so we are speeding up things. At the same time, we can include different abnormal scenarios like falls, that is very seldomly occur, and the operators has to be trained on them. Now this system allows us to train people for for their reactive responses. So while the virtual reactor is bioreactor is running, they can observe the graph, these the data, and at the same time they can rectify or interact with the virtual bioreactor and then see the consequences and the effects on the graph itself. So for some reason, though it is PID controlled, but for maybe for some reason the pH level is getting down, let's say, and we have set the alarm value at 4.9. So when the pH is getting down, the system will try to include alkaline, and here we can see the system after a certain value, the system will, and this is the pH calibration setting as well we have in the game. So yeah, so we so the see the pH is really dipping down. At the same time, like the dissolved oxygen is also getting down. So but before it reaches 4.9, again the alkaline is pumped into the system. So and this is the second uh, spike of alkaline. Now it will definitely, like we have designed the game in a way that so it will come down, and during this period let us walk around the virtual bioreactor. And yeah, this is the air filter and the other equipments. So since we have simulated the fault, so the pH level is getting down, and after a point of time, yeah, when it reaches 4.9, there is an alarm. Now the system tries to again burst some um, alkaline in with some alkaline in, but still like it will go down because we have designed the system like this. Now when this sort of scenarios occurs, there are some set of actions that the operator could do. uh, so there are some things they need to check. So first of all, they may need to check like three things: if the pH sensor is calibrated and is giving right value, maybe if the alkaline bottle is empty or not, like it has ample alkaline in it, or the pipes is strangled or not. So these are the basic things that an operator may check. So for example, like uh, the operator could do the pH calibration to check. So this is the calibration. So this is the temperature probe. So this setting is not exactly similar to the real world setting, but yeah, it is very close to it. So the point here is like we can show that it can be simulated. And there are definitely options for betterment in future. We will add real 3D models of the calibrator and all. So yeah, so after washing it with the deionized water, now the trainee should wash it with pH 7. Now he needs to, yeah, the alarm is a bit annoying, but now the probe is set on the pH 7 buffer. Now the on the calibrator, pH 7 has to be set. Yeah. And afterwards, yeah, he is washing. with the deionized water again. Now it has to be washed with pH 4 buffer. And this is the pH 4. So while it is calibrated to check if the so we are taking some samples, and of course this is not the exact way of taking sterilized sample, but it's just to show that these are the actions an operator should do. So now when you check, the value is 4.85, which is roughly the value of the system. So it shows like the pH calibrate, the pH probe may not be faulty. Now the next thing what the operator should check is if the acid bottle and alkaline bottle is empty or not. Yeah, apparently it's not empty, and you can see but you can see like the pipe is strangled for the alkaline, so we just try to fix it, and as soon as we fix it we can see there is inclination of the pH. In real life it does not go like that, it does not come certainly into level, but the point is to show that it the training could be given like this. And as we can see, like because of the pH there was a dip in the dissolved oxygen as well, and these are the burst of alkaline that was put into the system during the pH or while the pH was going down. Now this was a case of tangled pipes, but it could be a case where the alkaline bottle was empty, so we can show that as well. Yeah, the bottle could go empty, and we can also make the pH probe faulty by showing um, a value which is not same as the graph has suggested. So these are the only three faults that we showed here, we considered, and we can see like while we are interacting with the bioreactor, and we can reactively respond on the faults. Now the second stage, in the second stage we will try to include the possible faults related to dissolved oxygen and other parameters as well, like the starter motor, and so we can build on this platform, and yeah, and we can train people, we can measure, we can assess their response time, how many falls they are doing, and and this is how we will try to train operators in virtual bioreactor system. Thank you very much.